So today I am gonna discuss the subjective paper of TIFR 2024. So as I mentioned earlier, so I discussed the third question already. The third question I will share the link in the description also. The third question of the descriptive paper TIFR 2024, and this is the first question you can see. Okay. So this is a mathematical physics question, and please pause the video first and read the entire question. Okay, the first part, second part, all the things read carefully entire question, pause the video and give it a try, and then look at the solution. Okay, so now let me start the solution. So as you already read the question, you will certainly observe that if you did this first part, if you are able to do the first part, then you are done. Okay, so the entire question is then easy, step by step you can do all this, at least some of this. Okay, but if you don't able to solve the first part, then you will not be able to do the entire question. So this is actually a tragedy, bit tragic. So yeah, let's try to understand that how you can solve the first part, and then step by step we will go to the next parts. Okay, so first write the differential equation they are telling. So d2y dx2 minus b square into x minus a minus x whole square y is equal to ui. Okay, and look at the statements. A, B, E are real constant, and look this statement also carefully. Yx and dy dx vanishes at x tends to plus minus infinity. Okay, this is also an important part. Okay, now they are giving you the hint to go step by step. First, consider the equation at x tends to plus infinity, and let the solution y infinity is e to the power minus mu x to the power lambda. So in this limit, find mu and lambda. Okay. So let me first give you some hint actually. So they are telling that y goes to 0 at x tends to plus minus infinity. Okay. And dy dx also tends to 0 at x tends to plus minus infinity. And they are telling you y is some function of e to the power minus mu x to the power lambda. So from these two conditions, can you predict something about lambda? What should be lambda? Can you predict something? So pause the video and think a little bit. So I will tell you that what should be the value. I mean, you cannot get the value of lambda, but you can predict something, that what should be lambda, how lambda should look. So you can remember from harmonic oscillator, simple harmonic oscillator, that a ground state is e to the power minus alpha x square by 2, where alpha is m omega by h cross. Okay, and this wave function is exactly like this. Ah, so it vanishes at x tends to plus minus infinity. Okay, so you can certainly not tell that lambda should be is equal to 2, but lambda can be 2, 4, 6, some even number. You can certainly tell that. Okay, so it can be to the power minus mu x to the power 4. Okay, this can be also a solution, but you can already guess from these two conditions the lambda should be some even number. Okay, so this is a good thing, and after deriving mu and lambda, you can certainly verify that these two conditions are satisfied. Okay. Now get back to our original solution, that how can we find mu and lambda. So first go with that technique. So dy dx. So y is e to the power minus mu into x to the power lambda. So what is dy dx? Dy dx is equal to e to the power minus mu x to the power lambda. Then there is mu minus mu here, lambda into x to the power lambda minus 1. So derivative of this part, the upper part. So minus mu lambda x to the power lambda minus 1 e to the power minus mu x to the power lambda. Okay. Now what is d2y dx2? d2y dx2 is minus mu lambda is there. Now take the derivative of this part first. So lambda minus 1 into x to the power lambda minus 2. Now take this part fixed and derivative of this. So it will again minus mu lambda x to the power lambda minus 1, and there is already a x to the power lambda minus 1 sitting here, so multiply it by 2 and e to the power minus x to the power lambda. Okay, so yeah, there is also a e to the power minus x to the power lambda. I forgot to write this. So yeah, so minus mu lambda e to the power minus mu x to the power lambda. Take this common. Lambda minus 1 into x to the power lambda minus 2 minus mu lambda into x to the power 2 lambda minus 2. Okay, so this is the d2y dx2. Okay, now what is minus b square into x minus a minus x whole square, minus x whole square. Okay, so if you put x tends to plus infinity, then you can neglect this term. Okay, at the first time this come to your mind, may come to your mind, but you will be wrong. Okay, so do the expansion first and then put x tends to plus infinity, otherwise you will lose some terms. Okay, so I will show you immediately this term. If you expand x square by a square minus 2 plus a square by x square. So if you don't expand this and just put x is equal to infinity and neglect this term, then you will only get this term. You will lose this term minus 2. So first do the expansion, okay? Otherwise you will lose term. Now put x tends to infinity, then you will surely lose this term. Okay, this term goes to 0. So at x tends to plus infinity, this term will be like minus b square x square by a square minus 2. Now we have derived all the things, what is d2y dx2 and what is this term at x tends to infinity. Now write all these things. Okay, so d2y dx2 is minus mu lambda into lambda minus 1 lambda minus 1 into e to the power, sorry, not e to the power, x to the power lambda minus 2 plus mu square lambda square, minus mu lambda here, minus mu lambda here, mu square lambda square x to the power 2 lambda minus 2. I am not writing this e to the power minus mu x to the power lambda, because if you write y is equal to this term, so there is also y, there is also y, so e to the power minus mu x to the power lambda will cut out. Okay, so it will not be present in the expression. Okay, so minus b square into x square by a square minus 2 is equal to e. So I emit the term e to the power minus mu x to the power lambda, because this term is common everywhere. Okay, so I am emitting this. Now look something carefully. Okay, let me simplify a bit more. Mu square lambda square x to the power 2 lambda minus 2 minus mu lambda into lambda minus 1 x to the power lambda minus 2 is equal to b square x square by a square, okay, plus e minus 2b. Okay, so this is the expression. Now think of x tends to plus infinity. Okay, so we already emit one term, x tends to infinity. Now at x tends to infinity, this term will surely blow up, and this is a huge contribution. Okay, and this term is a constant, it will almost, I mean, negligible contribution compared to this. Okay, so neglect this term. Okay, neglect this term at x tends to plus infinity limit. Okay, so this term will have almost negligible contribution compared to this. Okay, now compare these two terms. Compare these two terms. Which term will has more diverging value? Okay, so lambda minus 2 is surely less than 2 lambda minus 2. Okay, so this term, this the power of this term is more. If lambda less than 2, then this will be a different case. Okay, but I will already set mentioned that lambda cannot be less than 2. Okay, lambda should be greater than 2, like 2, 4, 6, even number sum. Okay, so lambda should be surely greater than 2. If lambda is surely greater than 2, then this power is more value than this power. 2 lambda minus 2 is greater than lambda minus 2. So this will be the dominating contribution. This will have much less contribution at x tends to plus infinity. So from these two terms, you will get that this term will only survives and this term will, I mean, gone out because of the dominance of this term. Okay. Now compare this two. Okay, so your 2 lambda minus 2 is simply 2. So lambda is 2. Okay, now you immediately can solve that mu square lambda square is equal to b square by a square. Okay, so mu square lambda square is b square by a square, and you already solved lambda, so mu square is equal to b square by 4a square. That means mu is equal to b by 2a. So your y infinity is simply e to the power minus b by 2a x square. So this is like almost same at the harmonic ground state of simple harmonic oscillator. Okay, so yeah, so this is the main part of this question. They are giving on only 2 marks for this, but I think it should carry more than 5 marks. Okay, the rest of the things are easy. If you solve the first part, then rest of the things are very easy, you can do it. But this part is a bit tricky. So yeah, this is a tragic question actually. So if you can't solve this part, then you will not be able to solve the entire question. Now go step by step, and also you all of you guys can do it. So next part, they are telling that y is equal to y infinity into some u is the modulating function, and you have to find the differential equation of u. So simply write u is equal to e to the power minus bx square by 2a. So what will be your dy dx? Dy dx is equal to du dx, first derivative of this term, and secondly derivative of this term will give you a bx by a. Okay, so x square will give you a 2x, so minus b by 2a into 2x, so bx by a into e to the power minus bx square by 2. Okay, so this is dy dx. Now calculate d2y dx2. D2y dx2 is, first take the derivative of this part, that is d2u dx2 minus bu by a. Okay, minus bx by a du dx into e to the power minus bx square by 2a. Now take this part fixed and derivative of this part, so du dx minus bxu by a to minus bx by a into e to the power minus bx square by 2a. Okay, so now simplify a little bit. So d2y dx2 minus bx by a du dx minus bx by a du dx, so minus 2bx by a du dx. Okay, minus bu by a and plus b square x square by a square into u. Okay, into e to the power minus bx square by 2a. Now you have minus b square, and you have to calculate the first term. I mean this differential equation. I mean you have calculated d2y dx2. Now these two terms are left. Okay, this first term and the second term are left. So you have to subtract it, minus b square into x square by a square minus 2 plus a square by x square. Okay, and there is also u, so e to the power minus b by x square square is already there. Okay, and minus e into u. Okay, and this is the total term. Okay, so I am actually basically calculating the first differential equation, the d2y dx2 minus b square into x by a by x whole square minus e y is equal to 0. So I am basically write this differential equation here. Okay, so this is equal to 0. Okay, so now do a simplification little bit. So d2y dx2 d2u dx2 minus 2bx by a du dx and you can observe that this minus b square x square into u, here is a b square x square by square into u, these two term will cancel. Okay, so finally you will survive with plus u into 2b square minus e minus b by a minus b square a square by x square is equal to 0. I guess I am right. U is equal to 2b square minus b by a plus b square e and a square by x square. Yeah. Okay. So this will be the final term. So this is the differential equation of u. Now you have to identify that where x is equal to 0 is what kind of point, the ordinary or regular singular or irregular singular. So if you read the third part of the question, you can automatically guess that what would be x is equal to 0. So they are writing this as a power series solution. Okay, so definitely x will be a regular singular point. Okay, but how it is a regular singular point, let me tell you. So here you can observe that at x is equal to 0, suppose this term, the coefficient of du dx is p and the coefficient of u is equal to q. So p is not diverging at x is equal to 0. If there is x here in the denominator, then it will diverging, and it will also diverging, then it will be uh, sorry, if let me erase this, sorry, erase this, dx to 2bx by a. If x and y both are, I mean u px, let me write it first. If px and qx square both are diverging at x is equal to 0, then it is a irregular. Then it is a irregular singular point. Okay, but if px and qx square are finite, they are not diverging at x is equal to 0, then they are regular singular point. Okay, so if you multiply p with x square, then it will be 2bx cubed by a. Okay, x cubed by a. So it will surely convert at x is equal to 0. Its value is 0. And if you multiply q with x square, then this term will just cancel this x square. This is a constant, and these four other terms will go to 0 because of the multiplication of x square. So you will have a finite value minus b square square kind of thing. Okay, at x is equal to 0. So this both these things are finite at x is equal to 0. So it is a regular singular point. Okay, so these are the things. Now you have to do the power series solution. Okay, now they are telling that y is equal to, suppose, sum over a n into x to the power n plus alpha. N is equal to 0 to infinity, obviously. Now do the, sorry, this is u, not y. So what is your du dx? Look, you have to calculate. Now let me write it in a simplified way. Multiplied x square in both sides. So x square d2u dx2 minus 2bx cubed by a du dx plus u into x square into 2b square minus e minus b by a minus b square a square u is equal to 0. Okay, so you have to calculate x cube du dx and x square d2u dx2. Okay, so du dx is simply n n plus alpha x to the power n plus alpha minus 1. Okay, now if you multiply the x's cube, then it will definitely be minus 1 plus 3, that is plus 2. Okay, so that is x cube d2y dx2. And what will be your dy dx? Now what will be your d2u dx2? It will again n plus alpha into n plus alpha minus 1 x to the power n plus alpha minus 2. Okay, now if you multiply this by x square, then there will be a plus 2. So it will simply plus 2 minus 2 will be 0. Okay, so it will not remain anymore. Okay, Yeah, so these two will cancel and it will simply be x to the power n plus alpha. Sorry for the delay. Now write all these things together. So your n plus alpha into n plus alpha minus 1 into x to the power n plus alpha minus 2b by a x cube. So n plus alpha into x to the power n plus alpha minus 2, okay, plus 2b square minus e minus b by a into x, sorry, plus 2 x to the power n plus alpha plus 2 minus b square a square into x to the power n plus alpha, okay, is equal to 0, and all these things are a n with them, okay, so a n an an with them, okay. So this is the power series solution, okay, I mean power series form of this differential equation. Now what is the lowest power? Lowest power is x to the power n plus alpha here, x to the power n plus alpha here. These two terms have 2 x to the power n plus alpha plus 2, okay. So take the coefficients of this, so n plus alpha into n plus alpha minus 1 minus b squared a squared, and that is equal to 0. This is the identical equation of the power series solution. So now put n is equal to 0, then it will be alpha squared minus alpha minus b square a square is equal to 0. So alpha will be 1 plus minus root under 1 plus 4b square a square by 2, okay. So this is your alpha, sorry, this is your alpha. Okay. Now look at one thing. They are asking you that find the value of alpha and write down the leading order dependence of y on x as x tends to 0. So you found the value of alpha, but what is this? Find the leading order dependence of y on x as x tends to 0. Okay. So this you can see that alpha has two values. Let's say alpha plus is equal to 1 plus root under 1 plus 4b square by a square divided by 2, and alpha minus is equal to 1 minus root under 1 plus 4b square a square by 2. So now look at this term, 1 plus root under 1 plus 4b square by b square a square. So 4b square a square is surely greater than 0, it's a square and positive quantity. So 1 plus 4b square by a square surely greater than 1, and if you take a root under, then it will be surely greater than 1. Okay. So this term is actually a negative term, okay, because this term has the value more than 1. So this term is surely a positive term, but this term is a negative term, okay. Okay. So now x to the power alpha plus and compare x to the power alpha minus. As we see, alpha minus already a negative term, so if you alpha minus is a negative term, so let's say this value is x to the power some c, alpha plus is a value c, and alpha minus is a negative value, so it is minus d, so it is 1 by x to the power d, okay. So at x tends to 0, surely this term will diverge because it has d has the positive value. Okay, alpha has the alpha minus is negative, and take the negative sign outside. So it is actually I'm writing mod alpha minus. Okay, minus mod alpha minus kind of this. So at x tends to 0, this term will surely diverge. Okay, so the leading order contribution is from the alpha plus term. So you have to omit this solution. The alpha minus solution will not be there at x tends to 0. Okay, this is they are asking. Now finally they're asking the recursion relation. So just make this in plus 2 and in plus 2 here, in plus 2 here, in plus 2 here, and you will be done. So a in plus 2 into n plus alpha plus 2 into n plus alpha plus 1 minus b square a square is equal to an into 2b by a into n plus alpha minus 2b square minus e plus b by a, that is the relation of an plus 2 and an. So this is your recursion relation basically, and they are finally asking that what is the value of e, that it has a maximum value and then truncate. So you can, I don't know the exact way, but I did in this way in exam, that n is some n max. Okay, so your n max should be such that this term will go to 0. So 2b by a into n max plus alpha minus 2b square plus b by a, that should be is equal to your e. So I write in this way, but I have doubt in this part actually. But yeah, rest of the things are like this. Okay, so you can see that this problem has only the first part is actually a bit complicated. If you solve this first part, then you will be done. Okay, so as I say, this is a tragic question. And for subjective paper question, please, if you are preparing for the subjective paper, then please, and revising mathematical physics, please read, I mean, practice the power series solution extremely well. Okay, because these are the things that TIFR likes actually. So please practice these questions, because these questions are rarely come in any competitive exam like NET gate. Okay, so please practice these questions. Yeah, so that's it for today, and thank you.